Hi, welcome to this module titled Functions. My name is Mark Zamueda. A function is a block of code that's named. You can use that name, or you can use a variable that points to the function to execute that block of code. This is a very important part of JavaScript, and most of the code that you write will be part of a function. If you're not writing code inside a function, then you're writing it inside the global scope, which is pretty limited. Most of the code that you write, you'd want that to be reusable within functions. Let's see what we'll cover in this module. We'll start off by looking at function basics. We'll see how to declare them and how to call a function and the basic syntax for defining them. Next, we'll look at function expressions. It's common to take a function and store it in a variable. So a function doesn't necessarily need a name, but we at least need a variable pointing to the function. That's what function expressions are all about. We'll see how to pass information into a function, and that way the code block of the function can work with our data, and we can see how to get values out of the function. All functions return some value, and we'll see how that works. Next, we'll look at function scope. The code block of a function is very similar to the code block of an if statement or a for loop in that you can define variables that belong only to that function. Once the function finishes executing, the variables no longer exist. And there are a few other tricky things about scope that we'll learn about. Lastly, we'll use functions to modify our web page. We've been using one all along called showMessage, but we'll look at this in more detail, and we'll create at least one new function to modify the page. So let's get started and learn the basics of functions. One way to look at functions is that a function is a block of code with a name. And because it has a name, you can call it over and over. Most of the JavaScript code that you write will be within functions. Let's see how we create these. Here's an example function. We use the function keyword, and then we give the function a name. Here the name is showMessage. We follow that by opening and closing parentheses, and that's the evidence that we're working with a function here. We'll see in a future clip what goes in these parentheses. But for now, just know we have the name of the function, parentheses, followed by a block of code. We have opening and closing curly braces, and whatever's between these curly braces is referred to as the body of the function. This is the code that executes when we execute the function. And here's an example of some code. Between the curly braces, we call console.log, and we simply log out in a function, the string. And we can have any code here. We can have if statements, loops, we can call other functions, and we can even call ourselves as a function. But let's keep things simple for now. Once we have a function defined in this manner, let's see how we call it. So we're defining our function on top called showMessage, and then here is where we actually call the function. We execute it. We simply enter the name, followed by the opening and closing parentheses. That will execute the function. And you can see that we're calling showMessage twice. So the message will be shown twice in the console. And that's the main purpose of functions. If we have code that we want to execute multiple times, we generally put it in a function. Let's get this working in Visual Studio Code. And let's create our first function. I'll enter the function keyword, followed by a name. I'll call it logMessage. And I'll create the function body with the opening and closing curly braces, and I'll simply log out a message. So this defines the function. However, we're not executing it yet. When code executes here from top to bottom, the function will exist, but this code block will never execute. To get it to execute, we call the function. LogMessage, and opening and closing parentheses, and we end the line with a semicolon. So before I save this and execute it, let's open up the console. I'll save the code, and it shows here is a message. Now if we wanted to execute this again, we could simply call it again. And I'll save it, and the message shows twice. So those are the very basics of using functions. We use the function keyword, give the function a name, and enter the code we want in a code block. To call the function, we simply put the name followed by parentheses. There's another way to declare a function. It's called using a function expression, and we'll see that in the next clip. There's another popular way to declare a function and immediately store it in a variable. These are called function expressions. Let's see what they look like. So we already saw a function declaration right here. We use the function keyword followed by the function name. And that's called a function declaration or a function statement, but it's also very common to create what's called a function expression, which is right here. We create a function with the function keyword, we have our parentheses and our code block. but all of this gets assigned to a variable using the let statement. So here fn is our new variable name, which stands for function. And to call this function, we simply use the variable with the opening and closing parentheses. And these are two common ways to define functions: a function declaration or a function expression. Here's our code from the last clip, and let's change this into a function expression. I'll say let my function equal function, and the name of this function is optional. We don't need it. So I'll just take it out for now. And the way we would execute this function is through the variable name, my function. I'll save it. And we get our message showing. Now it is a best practice to give this function a name. It's not required, and often in code you don't see it. But if you give this function a name, debugging could be easier in the future. I'll just call it logging function. And if there did happen to be an error in the future, it would show up in the stack trace. So with this name, I'll also save it. And we get the same message. Just remember that we can't use this function name. Let me just copy it, and let's try to call it directly. I'll save it. And we get an error. I'll resume the debugger and go to the console. And you can see that it says logging function is not defined. So this function name here is only for debugging purposes. If we wanted to call the function, we use the variable name myFunction. I'll save it. And we get our message. So whether or not you use function expressions, as we see here, or the other style, which is a function declaration, it has other names too. Sometimes it's called a function statement, and sometimes it's called a function definition. But no matter which style you choose, it's up to you, if you want to use variables, or if you want to directly call function names. So we've seen how to declare functions and use them, but many times we need to pass information into a function. And that's what the parentheses are for. We'll learn about those in the next clip. It's very useful to be able to pass information into a function. That way the function can work with whatever data you send it. Let's see some examples. So we're declaring a function showMessage, but this time between the opening and closing parentheses, we have what's called a function parameter, message. And you can think of message now as a variable. Whatever information we pass to this function will be stored in message. And of course we use message like a variable. We console.log the value of message. So that's our function declaration, but let's call the function now. We call showMessage, and in the parentheses we pass it the string first message. And we'll call it again with another message, second message. So this way we can pass any information to showMessage and it'll be logged out to the console. And here's another example. If we look at showMessages, you can see that we have two parameters now, message and another message. It's important that they're separated by commas. So we can pass multiple types and values of information to a function just by listing several parameters separated by commas. This code just logs out message and another message. To call showMessages, we pass it the first argument. An argument is the actual value that we send to a function. So first message is the argument, and it gets stored in the parameter message. And we use a comma, and we pass another argument, second message, which gets stored in another message within the function. And we can have as many parameters and arguments as we'd like. Just make sure that they're separated by commas. Let's take a look at this in Visual Studio Code. So here we have our function expression from earlier, and let's add a parameter, message. And instead of logging out this string right here, we'll log out that new variable, message, which is actually a parameter, but it acts very much like a variable. Now when we call my function, we need to pass it an argument. And I'll just pass it hello for now. I'll save it. And we get hello showing up in the console. And we could have as many parameters as we'd like. Let's add one called first name. And just to make room, I'll remove the optional function name here. So we'll log out message, and we'll log out first name. Now, of course, we'd need to pass an argument for that parameter, first name. And I'll say John. I'll save it, and we get hello, John. Now, what happens if we accidentally or on purpose leave out this second argument here? So we're calling the function, but we're passing it one argument, hello, but it's expecting two different arguments here, one in message and one in first name. I'll save it. And we get hello and undefined as first name. So if you don't supply values for all of the parameters, they'll be set to undefined. Likewise, if we didn't pass any arguments here to the function, we just left the opening and closing parentheses, I'll save it, and we get undefined twice. And this is the source of many bugs. You always want to make sure that you're passing a function the correct values and the correct number of values. If you don't, the parameter values will be set to undefined. So that's how we send information into a function, but we can also get information out of the function. And we'll see that in the next clip. We saw how that when we create a function, we can specify parameters. And those are symbols to represent information coming into the function. We can also get information out of the function by using the return keyword. A function may or may not return a value. Let's see an example. We're declaring a function called getSecretCode, and there's one parameter, value. We create a new variable, code, and we set it to value times 42. And then we have our return statement. It will return the value of code, and that's how we get information out of a function. And looking below, we can see the call to getSecretCode, and we're passing it the number 2. So just to follow this line by line, this will execute our function. Code will become 2 times 42, which is 84, and then we'll return 84. So this function call, you can think of it as getting replaced by the value 84. So when we call console.log, it'll show 84. And the key thing to remember is that the function, including the name and the parentheses, you can think of that as getting replaced by the return value. So you can use functions in mathematical expressions or anywhere that you would use a value, including as an argument, as we see here. 84 is getting sent as an argument to console.log to print out. Let's see this in Visual Studio Code. Here's our code from the slide. I changed the console.log so that will show the message. I'll save it. And we get 84. That's what we expected. So getSecretCode, passing it a 2. Value became 2. Code became 2 times 42, which is 84. And then we returned code, the variable. So this is equivalent to calling showMessage, passing it 84. Let's see what happens if we forget to put a return statement. So I'll just comment this out for now. And in addition to showing the message, I'll console.log it. So I'll just log out another call to getSecretCode, passing it 2. I'll save it and we'll take a look in the console. And we get undefined. So if a function does not have a return statement, it implicitly returns undefined. So here we see an example where we're returning a variable, code. We could also return one of the parameters, value, or we could return an expression itself. We could leave out the let statement and just return value times 42. I'll save it. And we get the same thing, 84. And it's really up to your coding style how you'd like to do this. I'll just reverse this. And to me, this looks a bit cleaner because we're creating a variable code and we can follow this more easily. Likewise, this command here might look a little confusing. So one thing we could do is we could create a variable. We'll let secret code equal the call to getSecretCode, passing it 2. And then when we show message, we can just show secret code. And this is equivalent to what we had. It just looks a little bit cleaner because we separated it out into 2 lines of code, and we're using a very clear variable name, secret code. So it really depends upon your coding style. I would prefer this over putting the function call right here within showMessage, but it's up to you. The next thing we need to look at is function scope, and we'll look at that in the next clip. Functions have their own scope. That means that the parameters and local variables to that function only exist within that function and subfunctions. Once the function completes execution, any parameters and local variables disappear. Let's see an example. We have a function similar to what we saw before. It's called getSecretCode, and it's using a local variable. We're declaring code within the function's code block, and we're returning code. So we can go ahead and call this function just to make sure it executes. But what happens when we try to log out code? Remember, code was declared within the function. We end up getting a reference error. Code is undefined. So our code right here has no idea what happened in that function. Once the function completed execution, the variable code here no longer existed. So that's why JavaScript doesn't even know that code existed. We call that being out of scope. So functions do have their own scope, and that's a good thing. That way we can encapsulate code and make sure it doesn't leak out into the surrounding code. Let's see some more examples. So here's our code from the last clip. We're declaring code right here, within the function, let's showMessage code and see what happens. I'll save it. And we get an error. It's paused in the debugger, so I'll resume. I'll go to the console, and we get the error that we thought we'd get. Code is not defined. So functions have their own scope. Now what happens if we declare a variable outside the function before the function is defined? Let's let key equal 42, and then within the function, we'll execute value times key. And let's showMessage secret code. So we want to see if key, which is declared outside the function, is accessible inside the function right here. I'll save it. And it is. We get the value 84. So functions have access to the entire outer scope. As long as there's a variable or something else defined outside the function, as we see with key right here, any newly declared functions can use it. But of course, this doesn't work the other way. When we have a local variable in the function called code, once this function finishes execution, code no longer exists. And you'll very often see nested functions. That's a function within another function. Let's create one here. We'll create a function expression. Let keyGenerator equal function. And for simplicity, let's create a variable. We'll let key equal, this time let's say 12, and let's log that out. We'll say in keyGenerator, the function, and the value of key. And we'll go ahead and return key. Here, instead of key, we'll call the function keyGenerator. And we don't pass it any arguments. But before we exit, let's console.log in getSecretCode, and we'll show key. Let's see what we get. I'll save it, and we get in keyGenerator 12, and that makes sense because in our function here, we specifically set key equal to 12, and we returned it. However, in getSecretCode, it returns 42. So when we use the variable key right here, you have to remember that this function finished executing, so key no longer exists. This key refers to the outer key, which was defined outside of the function before it, and we get the 42 right here. So you always need to be aware of function scope. We're using the same variable name here as well as here, so you have to keep track as a developer of which variable is active. And if we use the same variable name within a function, that will override any variable outside of it with the exact same name. So the important takeaway here is that when a function finishes executing, all of its local variables, such as key right here, will disappear. And if something's declared in the global scope right here, it will always stick around because that's the outermost scope. And having functions nested within functions is very common in JavaScript. You should really work around with this and make lots of examples, because when you're looking at other people's code and other projects, you're sure to see functions nested in functions and nested in other functions. In the next clip, we'll take a look at the function we already created earlier in the course called showMessage, and we'll create some more functions that could be useful when changing a web page. Early on in this course, we actually created a function called showMessage, and that's what enabled us to write out a message directly to the web page. Let's take a look at that function. Let's start off by going to index.html, and I'll scroll down to right before the body tag. And this is where we added two scripts. Mostly we've been working in home.js, but you might have forgotten that we also added a utils.js. Let's look at that. I'll make some room, and I'll expand out the window because it's a long line. And we can see a function here. We're declaring a function using the function keyword, and it's called showMessage. And this is what we've been continually calling throughout this course, is this function. Within the parentheses, we have one parameter, message. Now, we still haven't learned a lot about objects in detail. We'll be learning about that in the next course module. But for now, just know that document is an object that refers to the whole web page. And we specify dot on the object, and we call a special kind of function on that object. Normally, you call a function that's attached to an object a method, but those terms are interchangeable. You can think of getElementById as a function, and we're passing it message. Then we access the text content of that object, and we set it to message, our parameter. So whatever message we pass to showMessage becomes the text content of the element with ID of message. And let's just look at our web page again. I'll go to index.html, and I'll search for getAgrip right here. And you'll remember that we added the ID message so that we could access this h1 tag within JavaScript. Another thing we might want to change is this value here, 20% off. So let's give our h2 tag here another ID. Let's call it %off. So remember, the ID is %-off, and that's how we can access this element. So I'll save the HTML file, go back to utils.js, and let's create a new function to change the %. We'll call the function change %off, and we'll pass it the percentage. Now to change that line, we do it in a similar way as we've done in showMessage. Document.getElementById, and remember the ID was %off. And we want to access the text content, and we want to set it to our parameter, percentage. But we want to set it to more than just that. We also want to add a % and the word off. And I'll show you why we do that. If we look at index.html, you can see that the actual string is the percentage, 20, and the % symbol, and off. So I'll just make sure we end this line with a semicolon, and I'll save it, but we're not executing this yet. Let's go ahead and we'll go back to home.js, and we'll execute this function, change %off. Change %off, and let's pass it 30. I'll collapse the editor, and I'll save it. And now we get 30% off. If we change it to 32, I'll save it. We get 32% off. So now we're using a function to change our web page. And this could be very useful. There might be several places that we'd like to change on a web page, and we could do it all within one function. Remember, these functions, they currently have just one line in the function body, but you could place as many lines of code in here as you'd like. So we're just starting off changing our web page, but we have all the tools to work with that now. The last final piece of the puzzle is to learn a little bit more about objects, and then we can go ahead and start making big changes to our web pages. But as far as functions go, we know everything we need to know. Let's wrap up this module with a summary. In this module, we learned all about functions. We saw how to declare a function using the function keyword and then naming the function. We have parentheses for optional parameters and a body of code between curly braces. Another way we could declare a function is as a function expression. We use the function keyword and an optional name. Here we don't have one. The parentheses and the curly braces for the code block. And we assign all of that to a variable so that we can reuse it and call it as needed. We saw how to pass information into a function. Basically, when we declare the function, we specify parameters. Here we have 3 parameters, A, B, and C. So when we call my function, we would pass these 3 values to be used within the function. Functions also return values. We use the return keyword and whatever value we'd like to return. It can be a variable, a parameter, any expression, a function call, but whatever we return, it's just a single value. We also looked at function scope. We saw how functions have their own variables, called local variables, that disappear once the function finishes execution. We also saw how functions can reach outside of themselves to the outer scope and retrieve variables there. And if you run into any kind of naming conflict, a function will always pick a variable in the local scope or closest to the local scope. Finally, we saw how to modify web pages by using functions. We've been using the showMessage function all along. It wasn't until now that we were able to explain it in more detail, but we saw how functions can be useful in modifying web pages. So that wraps up functions. The next big feature that we need to learn in order to truly modify web pages is the subject of objects. After all, a web page is one big object. And by learning about objects, we can learn to show or hide parts of the web page, respond to button clicks with events, and manipulate the page however we'd like. So the next course module will learn all about objects and the document object, which holds the web page. I'll see you there.